Today we're going to look at constant velocity and graphing from position time to velocity time, and later starting with velocity time and then sketching the position time graphs. Again, this is for constant velocity. We can tell that this is constant velocity because the slope here is going to be constant for each of these segments that we have on the position versus time graph. So this would be like a position versus time graph. So if we look at this section right here, first, we can get slope by doing rise over run, and that's going to give us the velocity because it's showing how far we go up, which would be from 3 to 9, which is going to be a delta x of 6 meters, and then the run would be from time equals 0 to time equals 3. So our change in time would be equal to 3 seconds. So 6 meters over 3 seconds, the rise over run, will give us then a speed of 2 meters per second. And now over here I have a velocity versus time graph. So I'm going to go ahead and plot the velocity value that I have, which is true for the first 3 seconds, on this graph. Since it's a constant of 2 for those first 3 seconds, then I'm going to just plot it as 2 for the first 1, 2, 3 seconds. 1, 2, 3 seconds. So it's being plotted as a y-axis value on my velocity time graph. This is a different graph. This is going to be velocity now on the y-axis versus time on the x-axis. If I keep going over here, velocity is equal to 0. That's from time 3 to 5 seconds, so it's just going to drop down here. It doesn't matter if you connect them or if you don't, but it's going to drop step right down to 0, and that's going to be from 3 to 5 seconds. And then from 5 to 8 seconds is the next segment, and that's going to be going down 3 meters for every 1 second. Right? I could do the whole thing like I did over here, or I can just figure out how much it's going up or down each second. And that's going to be true for all of these, right? Down 3 over 1, down 3 over 1. So that means it's going to be jumping at time equals 5 to negative 3 meters per second. That negative 3 meters per second is going to be plotted as a y-axis value, right? Velocity is equal to negative 3, and that's going to go right here at time equals 5 to time equals 8 seconds. Again, we can connect this or not, it doesn't really matter. And then from here, it's going to be 8 to 10 seconds. It's going to be going up 1 and over 1, up 1 over 1. And so that is going to be a slope of 1 meter per second. And 1 meter per second is going to be up here at v equals 1. And that's from 8 to 9 seconds. I should write here, this is v equals negative 3, so it's more clear. Okay, let's look at another one. In this position time graph, we're looking again at slopes to get the velocities that we're going to plot as y-axis values here. I'm going to go more quickly now. So although I'm starting at 1, that's giving me my beginning x value, my beginning position value. That's like where I am on the tape measure. I'm starting at a 1 meter mark on the tape measure. What I care about if I want to get velocity is how is that changing over time, and it's not. So the slope here is 0, right? So if the speed is 0 for the first 2 seconds, then that's going to be v equals 0 for the first 2 seconds. It's then going to move up the tape measure, right, to 1.5, 2, 2.5, all the way up to 4. Okay, so it looks like in 1 second it's going up 1 and over 1 second. So that's going to mean that it's 1 meter per second. It's careful with the 2 boxes, right, because each box is not 1. In this case, each box is 0.5. So in 1 second, it's going up only 1. So that means that v is equal to 1 meter per second. And that's going to be until the 5-second mark. Now it looks like we're going to immediately change speeds to a negative velocity. This of course means that it's moving backwards because it's taking that tape measure value that it has at 4 meters right at time equals 5, and it's going to start subtracting distance, which is going to get it closer and closer to 0 meters, although it's only going to reach 2.5. So now we're going to be subtracting. Remember the negative slope just simply means that you're moving backwards on a position time graph. So we're going to be moving down 1, which is really 0.5 each second. And so in this case it's going to be 0.5. So it's going to be negative 0.5. Negative 0.5 is right about here, and that's until the 8-second mark. So right in between these two. So V equals negative 0.5 meters per second. After time equals 8, it's going to be at the 2.5 meter mark on the tape measure, but it's not moving anywhere. It's just standing at that 2.5 meter mark and holding that position constant, which means it's going to now be at 0. Velocity, 0 velocity. If we want to work backwards, I'm going to make this into a separate video so that we can look at how to do velocity time and position time in a similar way that we just did